Okay, welcome back. So this is how to solve exponential equations in pre-calculus. Let's take a problem like number 8 here. This is last night's homework, not the one I just gave you. It's the one that you had after the test. So the goal here is to be able to solve this. And the issue is that I've got multiple terms over on this side. You see that there's x up in the exponent, which makes us think about doing what? Logs are typically the way we get things out of the exponents. But in this case, what we're going to really do is try to consolidate the bases. So I'm going to see that this is 1/12, this is 12, this is 12. Looks like 12 is my base. First, I'm going to change 1/12 into 12 to the what? Good. 12 to the -1. And that's raised to the 4x plus 3. And we're multiplying that times 12 raised to the x squared. That's equal to 12 to the 2x plus 13. Now what I need to do is take these two terms and consolidate them. And so I'm going to think about my rules of exponents. If I have a to the x times a to the y, what does that become? Good. A to the x plus y. Whereas when I have a to the x raised to the y power, very good, a to the x times y. So these are the two rules I'm really thinking about. So in this case, I've got 12 to the -1 raised to this power. So what do I do between these two components? Multiply, right?
Oh, yeah.
So I'm going to get 12 to the -4x minus 3. And I've still got times 12 to the x squared equals 12 to the 2x plus 13. And now I want to consolidate these two. They're both base 12. So it's like this first one. I can do this as a single term, 12 to the, and now I'm just adding these all up in the exponent. And since I've got a single term raised to a power equals that same single term raised to a power, I can effectively just drop the 12s away and these things fall down onto the main line. Really what I'm doing is I'm taking log base 12 of both sides and then moving this out front with the power rule. But it ends up looking like x squared minus 4x minus 3 equals 2x plus 13. And that equation is what kind of equation? By the way, anyone who missed the test and didn't get this, they're right here next to the thing. This is a quadratic, right? And when we solve a quadratic, we always try to get everything over to one side. So I'm going to subtract the 2x and the 13. So I get x squared minus 6x minus 16 equals 0. And then I'll use my diamond process, put -16 as the product, -6 as the sum. I'm looking for two numbers that multiply to make a -16 at the same time adding to a -6. So -8 and +2. That means this has got to be x squared minus 8x plus 2x minus 16. And I factor by grouping. Pull out an x minus 8. Pull out a 2, x minus 8. And this becomes x plus 2 times x minus 8 equals 0. And then I apply the zero product property to say either x plus 2 equals 0, so x equals -2, or x minus 8 equals 0, x equals 8. When I'm done with this, I need to check for extraneous solutions. Are there any domain restrictions on the original problem? There aren't. I don't have any rational things where the denominators can't be 0. I don't have any square roots where arguments can't be negatives. I don't have any logs where the arguments can't be 0 or negative. Any questions on solving exponential equations? Again, the instructions up here tell you to use a common base, properties of exponents to simplify and solve. Today's work is going to ask us to move into logarithmic equations. So let's take a look at, for example, number 2 here. We want a condensed logarithm on each side. In this case, that's already done for us. We want to use the one-to-one property. In other words, we get the same log base on both sides, then x equals y. In this case, do we already have a single term and another single term, both with the same base logs? We do. Therefore, we could do e to the both sides effectively and cancel those, leaving us with just k squared minus 4k equals k plus 14. This is now what kind of equation? Quadratic? Quadratic. Good. And when we solve quadratic, is our strategy to get all the variables to one side, the constants to the other? Or is it get everything to one side set equal to 0? Yep. So k squared minus 5k minus 14 equals 0. I'm pretty good at factoring. You might need to take a couple steps to get there, but it's k minus 7 and k plus 2. And then I apply the zero product property. K equals 7. K equals negative 2. Are any of these extraneous solutions? Well, let's see. If I plug in 7, that's a positive number. That's a positive number, so that's fine. If I plug in negative 2, that's 12. This is 4 plus 8, it's 12. Yep, that works as well. So both of these are valid solutions. That's the end. Let's do a harder one. Take a look at number 4. What's wrong with it? What makes it harder? The 1/3 is one problem. And we can move that with a power rule up to here, can't we? Log base 7 of 8 to the 1/3. We'll deal with that in just a second. Well, let's deal with it now. What does a 1/3 exponent mean? Good, cube root. And so remember, if we're taking a cube root, nice, of 8, what we're saying is what's multiplied times itself 3 times inside here. So I factor 8 into 2 times 2 times 2. They all match up and come out as a single 2. So this becomes log base 7 of a regular 2. What about this side? Good. You can condense it. And that was the terminology we used before. If we subtract 2 logs of the same base, then we can treat that as a single log where the arguments are what? Divided. Now, do I have a single term on the left and a single term on the right? Yes. Both with the same base? I do. So I can get rid of the log base 7s on both sides. I get w plus 6 for 5w minus 3 is equal to 2. How do I solve that? Multiply the top by the bottom. Okay, or cross multiply. W plus 6 is equal to 2 times this, which would be 10w minus 6. That's a linear equation. Great, I know how to work these. So I'll subtract 10w minus 9w, and I'll subtract 12 is negative 12. Subtract 6 to make negative 12. So my w becomes 12/9, which reduces to 4/3. Do I have to concern myself with anything, or can I just say, yeah, I win? It might be extraneous. Might be extraneous. I got to look and see if this works, if it fits within the domain. So what's my domain of this part? Good. W plus 6 has to be greater than 0, so w has to be greater than negative 6. Is this greater than negative 6? Yes. It is. Great. Let's look at this other one. 5w minus 3 has to be greater than 0. So 5w has to be greater than 3. So w has to be greater than 3/5. We've got 4/3. It's kind of hard to compare fractions, but is this more than 1 or less than 1? And is this more than 1 or less than 1? Therefore, this one has to be greater. So I'm good, right? I needed it to be greater than this. It is. This is my solution. Okay? They're going to take some focus and some energy. But this is the way we're going to solve these. If we look at one more, let's look at yeah. All right. Let's take a look at number 6. Page 2. How can we start to peel away the onion layers?
Divide by 2.
We could divide by -2, couldn't we? That's nice. Not much more I can do. How do I get this 4 minus x out of the exponent?
Equivalent bases.
I could make equivalent bases. You're right. Are we going to find an equivalent base with 8 and 25? We are not. This is 5 times 5, and this is 2 times 2 times 2, and that's all there is. Nothing shared. But it's in the exponent. So can I apply some idea of logs to get it down? Right? We can change it from exponential form into log. I pull the 8 away. The 4 minus x drops down. And that 8 was a base before, and it's going to be a base forever. Now it's the base of the log. And then if I want to resolve this, I'm going to subtract 4 from both sides. And then as I divide that -1, I get x equals, really ends up flipping it. It becomes negative log base a to 25 plus 4. I'm going to treat it as 4 minus log base a to 25. Now, if we were just trying to get a simplified solution, this would be fine. It's nice and simplified, but we who know logs know that log base 8 of 25 is a little bit ugly. How could I use a calculator to evaluate that? Which ln, change a base. So in other words, I can treat this as ln of 25 divided by ln of 8. Right? I do the change of base to this, or I can choose any base. It could be log 25 over log of 8, or ln of 25 over ln of 8. And let's try with our calculators to see if we can evaluate what that is. 4 minus, I'm going to open up some parentheses and say ln 25. And notice that it opens up parentheses for me at the beginning of the 25. So I have to close that and then divide it by ln of 8. Close that, and then close the whole thing. There's a lot of parentheses going on here. In this case, I get approximately 2.45. Okay, let's just try it. You guys, please get to work on resolving these logarithmic equations and exponential equations. I'll circulate.